Hi, welcome to Vectors Lesson 2. Today we're going to be adding, subtracting and multiplying vectors. Just a wee reminder, where you see the pencil icon in the top right hand corner, if you could copy the notes into your notes jotter and do the work into your class jotter, please. Thanks. Now, the reason we're going to look at adding, subtracting and multiplying vectors today is because in this lesson we're going to be asked to find resultant vectors. So we need to know what a resultant vector is, and it's quite straightforward really. A resultant vector is just the vector we get when we add or subtract vectors together or their multiples. So for example, if we had a vector A and a vector B, we could be asked to find the vector A add B. We could be asked to find the resultant vector B subtract A, or we could be asked to find, for example, 2A add 3B. All these are just examples of resultant vectors. Now, like any other vector, resultant vectors can be represented by column vectors or by a directed line segment diagram, and we will look at both these types and also calculating the magnitude of resultant vectors today. Right, let's have a look at the first example on adding vectors. So in this example, we are asked to draw a diagram to represent the vector u plus v. We've also been asked to write the components of the resultant vector. So remember, that's just the column vector that would represent u plus v. And then lastly, we've been asked to find the magnitude, that's the length of the vector u plus v. So before we can do this, we need to get the column vectors of u and v individually. So let's look at u first of all. From start to finish, with u, we need to go right 5 and up 2. So that gives us a column vector of 5, 2. If we look at v, we need to go right 3 and down 4. So that gives us a column vector of 3, negative 4. For part 1, in order to draw the diagram of the vector u plus v, we need to choose a starting point, and from that point we're going to draw vector u. So that's, we go 5 across and 2 up, draw the vector in and label it with the arrow pointing in the right direction. From the end of vector u, we're now going to draw vector v. So we're going to go 3 across and 4 down and draw in vector v again, making sure that we label and put the arrow in the right direction. And that will give us our finish point. So we can see from this that there's a more direct route. So if we go straight from the start to the finish, this is the shortest route from u to the end of v. So therefore that's u plus v. We can get the component vectors for this by tracing out the path from the start to the finish in the component form. So we would need to go across 8 and down 2. So therefore the component of u plus v is 8 minus 2. Now we can check this with a component calculation instead. So if we look at part 2, we want to find the components of the resultant vector u plus v. So we can write down the components of u, which is 5, 2, add the components of v, which is 3 minus 4. If we add the x components together, 5 plus 3, that gives us 8. And the y components, 2 add minus 4, that's negative 2. So we can see that we end up with the same component vector for u plus v, which should be the case. So we know our diagram is correct. And you can also see that it's much quicker and easier to do it as a calculation. So if you have the choice, do the calculation, but at National 5 you need to be able to draw the diagrams, so that's why you're being shown how to do both. Part 3 of the example is just to calculate the magnitude. So remember, we just do that using Pythagoras. So in order to do it, we need to know the column vector, but we've already worked that out in part 1 or part 2. So all we need to do is the square root of 8 squared plus negative 2 squared. That gives us a square root of 64 add 4. So it's a square root of 68 in total. Now, if you are in 5th or 6th year, you have done simplifying surds, so you would give your answer in the simplest surd form, which in this case is 2 root 17. However, if you're in 3rd or 4th year, just give your answer in a decimal form. So in this case, it would be 8.25 units. So that's how you draw your diagram to illustrate a resultant vector and calculate the components as well. Okay, so we'll have a go at a second example. Okay, let's have a wee look at example 2. This time we've been given two column vectors A and B, and we've been asked to draw the diagram to illustrate the vector A plus B. And for part 2 we want to state the component vectors of the resultant and calculate the magnitude of vector A plus B. Okay, so this time we'll need to draw vector A, so if we choose a starting point, and A is the vector 3, 5, so that means we go 3 to the right and 5 up. So if we draw vector A and label it with the arrow pointing in the right direction. Now from the end of vector A we're going to draw vector B. Vector B is the vector 3 minus 4, so that means 3 to the right and 4 down. So if we draw in vector B, that will give us our end point. So from the start to the end, vector A plus B, there we show the shortest route. Now we need to get the component vector of A plus B. So from the starting point, we need to go across 6 and then up 1. So our component vector of A plus B is 6, 1. So that's our diagram to illustrate the vector of A plus B. If we want to check the calculation for the component vector, A plus B would be 3, 5, add 3 minus 4. Adding the x components together, we get 3 plus 3 is 6, and then 5 add negative 4 is 1, so we get 6, 1, and we can see that that agrees with our diagram. To get the magnitude, now remember the symbol for magnitude has a vertical line either side of A plus B. So the magnitude of the vector, which is just the length, is the square root of 6 squared plus 1 squared. So that's the square root of 36 add 1, so the square root of 37 in total. If you are 5th or 6th year, again you can leave it as the square root of 37 because that's the simplest form. If you're 3rd or 4th year, you can square root that to 6.08 units. Okay, one last example on adding vectors. So again, here we have been given the component vectors A, which is 0, minus 5, and B, which is minus 3, 3. So we have to draw a diagram to illustrate the vector A add B, and same procedure as before, state the components of the resultant vector and calculate the magnitude of vector A plus B. So let's start by drawing the vector diagram. So we have our starting point. A is the vector 0, minus 5, so that means we move 0 horizontally, and minus 5 means we move 5 down the way. So no horizontal movement, just 5 down. So that is our vector A, making sure we label it with the arrow in the right direction. Now from the end of vector A, we draw vector B. B is minus 3, 5, so that means, minus 3, 3. So that means minus 3 is 3 to the left, and then 3 is 3 up. So we draw in our vector B, and that gives us our end point. So from start to finish, the shortest route is A plus B. Now if we want to get our component vector for that, we need to go from the start minus 3, left 3, remember left is minus, and then down 2, so that's minus 2. So our component vector for A plus B is minus 3, minus 2. We can check that with a column vector calculation. So A plus B in column vectors would be 0, minus 5, add minus 3, add 3, and that gives us minus 3, minus 2, which agrees with our diagram. To get the magnitude, we're just square rooting negative 3 squared plus negative 2 squared. Remember, when you square a negative, you always get a positive, so that will give us a square root of positive 9 plus 4. And we end up with the square root of 13. Again, that's a surd in its simplest form. So if you're 5th or 6th year, you can leave your answer in that form. For 3rd or 4th year, square root it to a decimal form of 3.61 units. Okay, now it's your turn to have a go at some questions. Okay, time for you to get a bit of practice on adding vectors. If you can pause the lesson here and go to worksheet exercise 2, complete question 1 and 2, and make sure you mark your questions when you've completed them, and then return here for the rest of today's lesson. Thanks. Okay, so now we're going to look at subtracting vectors, and it's quite straightforward really. We can just think of A minus B as A add negative B, okay? So in order to do that, we need to know what we mean by negative B. So if we have a look at the example, we have a vector B here. If we look at the components of this vector, we can see that we go 3 to the right and 4 down. So the components of vector B are 3, negative 4. Now the vector negative B is just the same vector but going in the opposite direction. So here we have negative B. So the component vectors of negative B are, you can see we need to go 3 to the left and 4 up. So our component vectors here are negative 3, 4. So if we compare the component vector of negative B with B, we can see that the x and y components just have the opposite signs. So the two things we need to remember for negative vectors, okay, is that they're the same size but go in the opposite direction, and we just swap the signs of the column vectors to get the negative vector. Okay, so let's have a look at actually subtracting some vectors now. Right, let's have a go at some examples then of subtracting vectors. So here we have example 1, and we are asked to draw a diagram to represent the vector u subtract v. Remember, we said we need to think of that as u add negative v. We want to state the components of the resultant vector, so remember that's just the column vector for u subtract v, and then we want to calculate the magnitude of u subtract v. So before we can draw the diagram, we need the column vectors of u and negative v. So let's look at vector u. We are going 4 to the right and 2 up, so the column vector is 4, 2. Now vector v is 2 to the right and 3 down, so that has the column vector 2, minus 3. However, we don't want vector v, we want vector negative v. So remember, all we do is swap the signs on the column vector. So negative v has a column vector of negative 2, 3. Now we can start to think about drawing our diagram. So we choose our start point, and from that point we're going to draw vector u. So 4 across and 2 up, and draw in vector u. From the end of vector u, remember this time we're adding on negative v because we're subtracting. Okay, so we go negative 2, 2 to the left and 3 up, and draw our vector negative v. This gives us our end point, our finishing point. So we can draw in the shortest route from the start to finish, and that is our vector u subtract v. We want to get the column vector. So again, from the start, we need to go across 2 and then up 5. So our column vector for u minus v is 2, 5. We can check that with a component vector calculation, just like we did with the addition. So if we are doing u subtract v, then that is 4, 2 subtract 2, negative 3. So looking at the x components, we have 4 minus 2. Looking at the y components, remember the double negative gives you a positive, so we have 2 add 3. So we end up with an overall component vector of 2, 5, and this agrees with our diagram. Lastly, we're being asked to calculate the magnitude, so remember that's just your Pythagoras. So we're doing the square root of 2 squared plus 5 squared. So the square root of 4 add 25, so the square root of a total of 29, and that will give us 5.39 units. That's how we draw a diagram to represent a vector subtraction and how we work out the resultant vector. Okay, let's look at example 2. So here we've been given two column vectors A and B. Vector A is the vector 2, 3 and B is the vector 4, 1. We're being asked to draw a diagram to illustrate vector A subtract B. So remember, we need to think of that as A add negative B. So we need to get the column vector for negative B. Remember, all we do is swap the signs. So negative B has a column vector of negative 4, negative 1. Now we can start thinking about drawing the diagram. So from our starting point, we're going to draw vector A, which is 2 to the right and 3 up. So we draw in vector A. From the end of vector A, we're going to draw vector negative B this time. So it's 4 to the left and 1 down. That gives us our end point, and we can draw in vector negative B. Now we can draw in the shortest vector from the start to the finish. So that gives us our shortest route for A subtract B. To get the column vector for this, we go from the start 2 to the left and 2 up. So we have a column vector of negative 2, 2. We can check this with a column vector calculation. So let's look at part 2. A subtract B would be 2, 3 subtract 4, 1. So we end up with 2 take away 4 and 3 take away 1, so negative 2, 2. Lastly, all we need to do is find the magnitude. So remember, that's just our Pythagoras again. So the magnitude of A subtract B is the square root of negative 2 squared plus 2 squared. So the square root of 4 plus 4, which is the square root of 8. And we can write that in the simplest third form of 2 root 2, or as a decimal of 2.83 units. And that's how we do our subtracting vectors examples. So now it's time for you to have a go at some questions. Your turn to have a go at some subtracting questions then. So if you go to your vectors worksheet exercise 2 and complete question 3 and 4 this time, make sure you mark your answers at the end. And the good news for you guys is, I know I said we would be doing multiplying vectors today, but I think actually by the time you've finished these questions, you'll have done enough for today's lesson. So we will do multiplying vectors on the next lesson. Make sure you upload your work for the week when you've done it, please. Thank you.